hopefully, over the weekend, you learned about the sig fig rule for multiplying and dividing with sig figs by spending a little time with Tyler DeWitt. And if you didn't, that's okay. We're going to go over it very briefly right now. If you have taken physics, you will already know this rule. So what I'd like you to do is take a minute, chat with your partner, see if you can remember what the rule is if you are multiplying or dividing with sig figs. So you are going to round your answer to the least number of sig figs in the calculation. So let's take this as an example. Oh, my telephone. Here we go, we have this, and if we plug that into our calculator, I'd like you guys to plug it into your calculator and see if you get the same number as me. Okay, so that is hopefully correct. Now, if you got then you entered it wrong. Okay, and I'll show you what you would need to do next time. Okay, so did anybody get this number? Yes, okay, I'm going to show you what takes place here. So you would have on your calculator, you would type 4.38 and you would type times and then 1,000. You don't need to put 0.0 because your calculator doesn't care whether you put a 0.0 or not. And then you would divide by 8.32. Now, we are actually dividing by 200 as well. So what you should be typing into your calculator is divided by 200 and not times 200. Okay, if you type in 4.38 times 1,000 divided by 8.32 times 200. What your calculator thinks that means is 4.38 times 1,000 divided by 8.32 times 200. Yes, if you put a times here, it assumes you want that number in the numerator. You would need to type divided by to make that number be in the denominator. Now there is another option as well, okay? You could also type in 4.38 times 1,000 divided by, and you could bracket 8.32 times 200, and that's perfectly good as well. Okay, I'm lazy. I don't like typing more keystrokes than I need to, so I like to do divide by, but for a lot of people, this just makes more sense to them, and so if you like that, then go for it, absolutely. Okay, so, but if you're dividing by two things, you either have to bracket the whole schmear or you have to go divide by, okay? Now, we were looking at this, once we got our number correct, we were looking at this for sig figs. And remember, we are going to round our number to the least number of sig figs in the calculation. So let's take a look at our sig figs here. How many sig figs in 4.38? 3. How many in 1,000.0? That's 5. How many in 8.32? That's 3. Remember, we had 5 up here because zeros on the right are significant if there is a decimal, and there is a decimal. And finally, how many sig figs in 200? Just 1, because we have no decimal, so there's just 1 sig fig. So who is our least number of sig figs in the question? Just the 1, okay? And so we would then say, okay, I can only have 1 sig fig. So now I'm going to round that. I'm going to look to the number to the right. And that's a 6, so it's bigger than 5. So I'm going to round it to 3, and my final answer would be 3. Okay? That's it. So basically, if you can use your calculator, and you can count the number of sig figs in each number in the calculation, you should be able to figure out what the final answer should be. It's just a matter of picking out who's the smallest number of sig figs and rounding to that number, okay? If that did not seem sufficient to you, if you're like, ooh, I would like a little more review on that, and you didn't watch the video with Tyler over the weekend, then maybe hang out with Tyler either tonight or tomorrow night after the test. Okay, so that's our sig fig rule for multiplying and dividing. Today we are going to look at the rule for adding and subtracting, and it is different. So let's go back to page, I think it might be page 14, but I'm not sure. Let's take a look. I think it's page 14. Yes, page 14. And the nice thing about this is we're going to get a little review for our test here. We're going to do some measuring to start with. Okay, so this is a review of, you know, what you need to write down when you're measuring something for your test here. Here's our ruler, and here is a stick. How would you record the length of this stick? Remember, you need 3 things. What are the 3 things you need? You need what you are measuring, so that would be the length of the stick, equals, and then we need 1 uncertain digit. This is 3 here, this is 4. So our smallest division is 1 centimeter. And so we can estimate to the 0.1. So 3 point something, 3.2, shall we say? That sound good? 3.2. If you want to do the enriched stuff, you would put plus or minus 0.1 centimeter, but that would be the enriched portion, okay? That's totally optional. You do not need to do that. Length of stick equals 3.2 centimeters is all that you need, okay? Now our second stick, we have 1, 2, 3, 4. We're just before the 5 centimeter mark. What is the size of our smallest division here? 0.1 centimeter. So the smallest division is 0.1 centimeters. That means that our answer, we should estimate one more position than that to the 0.01 centimeters. So let's take a look up close. This looks to be about 4.95, 4.96, somewhere in there. Yeah, somewhere in between 4.9 and 5.0. So length of stick 2 is 4.95. And if you wanted the uncertainty plus or minus 0.01, because the uncertain digit has to agree with the uncertainty, they're both in the hundredths place, centimeters. Oh yes, if anybody did not get unit 2, make sure you grab yourself one. Sorry about that, Ricardo. Now, if I want to combine these two lengths and add these two measurements together, what I'm going to do is I'm going to take my 3.2 and I'm going to add it to 4.95. And often when we are adding, we will line things up vertically and make sure our decimal points line up, okay? It's not necessary to line them up vertically. You can add, like, you know, this plus this in a straight line like that, but we'll show this to start with because it kind of is nice to see where your uncertain digits lie. Who is the uncertain digit in 3.2? The 2. Who is the uncertain digit in 4.95? The 5. So let's add these together, 3.2 plus 4.95. You can just do that on your calculator or in your head if you're smarter than I am. And we get 8.15. Now what you'll notice is that the 5 is uncertain. And that means that this 5 is also uncertain. Where did the 1 come from? It came from the 2 and the 9. The 2 is uncertain, which makes that 1 also uncertain. Is good? So if the 2 is uncertain, that means that the 1 here is uncertain. How many uncertain digits are we allowed in a measurement? We are allowed 1 uncertain digit. So what we have to do is we go to our very first uncertain digit, and then we round to that first uncertain digit. So our first uncertain digit is the 1. We look next door to the 5 and we say that's a 5, so it's going to have to round up. So this answer is then going to become 8.2 centimeters. So the rule for adding and subtracting is to round to the first uncertain digit. You may have heard this expressed in a different way if you've taken physics. Okay, they might say round to the least number of decimal places. That also works. Now the advantage of this one, round to the first uncertain digit, is that it works 100% of the time. The rounding to the least number of decimal places works unless you've got numbers that don't have any decimal places and the uncertain digits are like in the tens or the hundreds or the thousands. Okay, so I prefer the first rule. The second rule works okay 99% of the time, but if you want it to be right 100% of the time, you're going to round to the first uncertain digit. Or you can be like, oh, I have -1 decimals, but that messes people up sometimes too. So we're going to look at some more examples so you can see what I mean. Okay, so we're rounding to our first or largest uncertain digit. Let's take a look at these two different rocks on two different balances. So here we have rock A, and it says 143.0. Now, do you guys remember what happened on your electronic balance with that last digit? What did it do? Kind of flickered around. Yes, it did not stay put on one number, at least not most of the time. Did you guys notice that? Yeah? Okay, so that last digit was uncertain, and so what you might see is you might see 143.1. You might see 142.9, whoops, 2.9. And you might see our original number, which was the 143.0. So I would like you to tell your partner or the people around you which digit is uncertain and how many sig figs are in those numbers. So in each of those numbers, which is the uncertain digit and how many sig figs? So who is the uncertain digit there? What position? The 0.1 position, the 10th position, yes? It's this one here. Even though here we do have a 2, that's only because it 29 goes to 30 or 2.9 goes to 3.0. We're really only changing that last digit. Okay, so I'm just going to erase that because we don't really need that. There we go. Oh no, I'm erasing wrong. Okay, sorry. 42.9. How many sig figs in each of those measurements? 4 sig figs. Excellent. Now let's take a look at our other rock, rock B. Okay, so here's rock B. And at one moment, it weighs 180. But then it flickers, just like the other one, it flickers to 190. And then it flickers to 200. So once again, you're going to decide with your neighbors, what is the uncertain digit and how many sig figs? And those are the only numbers that show up. It keeps flickering back and forth between those 3 numbers. What do you guys think? Who's the uncertain digit there? Is it the hundreds? Is it the tens? Or is it the ones? It is the tens, because we're either going up by 10, right? We have 190 plus or minus 10. Yeah, it either goes up by 10 or it goes down by 10. Right? So our uncertain digit is the tens position. And that means how many sig figs? 2 sig figs, yes? Now we're going to take these 2 masses and we're going to combine it. So we want the combined mass of rock A plus rock B. Okay, so we're going to take 143.1 and we're going to add to that 190. And we're going to keep track of our uncertain digits. Okay, so this is doing it the uncertain digit method. The 1 is uncertain. And the 9 is uncertain. And you'll notice I've lined up the decimal places here. So my decimal place is going to be there. Whoa, what happened? There we go. Decimal's going to be there. And if you want to do this in your head, you can. I'm going to use my calculator because I'm lazy. 143.1 plus 190 equals, and I get 333.1. This one here makes this one uncertain. Yes? This 9 here makes this 3 uncertain. How many uncertain digits are we allowed to have? Just 1. So once you get to your first uncertain digit, the largest uncertain digit, you have to stop and round your number off. So we are going to need to round to here. That's our first uncertain digit. So we look to the right and we're going to round that off. And that's going to round to 3, 3. And you guys are going to tell me what you think of that answer. Do you like it? I've rounded to my uncertain digit. Or have I? What have I done that's wrong? I've taken a number that is approximately 300, yes? And I have rounded it to a number that is approximately 30. Yeah, I need a 0, okay? So don't make the mistake of just kind of cutting the number off. You have to keep like all the zeros at the end to keep it the same place values, okay? So you definitely need to have this 0 here. Okay, so that would be 330 grams. Just because it's good review for your test, how would you write this in scientific notation? Are you happy with what I've written? No, because this number here has 2 sig figs. So when you were like, oh shoot, you shouldn't have been, you should have stuck with your intuition because you were correct and I'm just messing with you. Okay, because this has 2 sig figs, this can have only 2 sig figs, which means that if you were to write that, you would see that and you would see a -1/2 on your test. So no. Yes. The previous one? Yes. Oh, this one here. 330. If it was 330.0, that would have 4 sig figs. And this is my uncertain digit. How can I write digits past my uncertain digit that are still significant? Does that make sense? Yeah. Like once you hit your uncertain digit, you can have digits after that, but they're insignificant. Yes. Oh no, I'm just okay. Okay. Is good now? Okay, awesome. Don't ever think, oh my God, I asked a stupid question, because you know what? The brain has glitches and you need to get those glitches sorted out. And if you don't get them sorted out, then you make mistakes on the test. Is this on your test? Is this on your test? No, because your test is on unit 1. What unit is this? Unit 2. On the other hand, we can do a little review while we're at it, right? Okay. So here are the steps. You are going to either underline or circle or highlight the uncertain digit. Do the math. I usually use a calculator. Feel free to use whatever method you want. And you're going to do that in each number. Then you are going to underline or circle or highlight the uncertain digits in the answer. Finally, you round your final answer to the first, which will be the largest uncertain digit. Now, we're going to take a look at these and see how you can also use round to the least number of decimal places, okay? And when that fails. So here we go. We have 35.43. Our last and uncertain digit is the 3. That is in the 100ths position, yes? And that is going to make the 100ths position of our answer, okay, this is our answer now, also uncertain. The second number that we're adding, 9.821, the 1 is uncertain. That is in the thousandths position, which will also make the 1000th position in our answer uncertain. But how many uncertain digits are we allowed? Only one. So we have to stop when we get to the 5 and say we're going to have to round off here because we're only allowed to have one. So we're going to take a look at the 5. We're going to look to the right. That is a 1. So it's going to stay as a 5. Okay. And so now we just have our one uncertain digit, and we've gotten rid of any digits after that because they are meaningless. Once you've hit your first uncertain digit, the rest of the digits are meaningless. Now let's look at decimal places. Does it still work? 35.43. How many decimal places does that number have? 2. 2 decimal places. Our other number here, how many decimal places? 3 decimal places. And look, how many decimal places did our answer have? 2 decimal places. So it would have worked if we rounded to the smallest number of decimal places, which is 2. Yes? Smallest number of decimal places. Let's try the next one. The number 9. It's how many sig figs in the number 9? 1, which means that that is our only digit and that is our uncertain digit. So we have an uncertain digit in the ones position. Which means in our answer, when we add 9 to 532 point whatever, we still have an uncertain digit in our ones position. In our second number, we have our uncertain digit in the thousandths position. Which means that in our answer, we also have uncertainty in our thousandths position. But remember, once we hit our first uncertain digit, everything after that is it meaningful or is it meaningless? Everything after our first uncertain digit is meaningless. Any digit after the first uncertain digit is meaningless. And we'll get a really good example of how meaningless it is a little bit later on. But what that means is that we really shouldn't be going past the ones position. That is our first uncertain digit. So we're going to have to say, okay, my first uncertain digit is the 1, so I need to look next door to the 1. That's a 6, so it should round up to 542. Okay? So, where was I going with this? Oh yes, we could look at decimal places. How many decimal places in the number 9? Are there any decimal places in the number 9? So there's 0 decimal places. In the 532.629, there are 3 decimal places. So our answer should have the smaller number of decimal places, which is 0 decimal places. Does it? Did it work? Does our answer have 0 decimal places? Yes, it does, because there is nothing after the decimal here. You can see no decimal places. And I'd like you to take note, the most common error I see from people is when they try and take the multiplication and division rule and use it for addition and subtraction. Because the multiplication and division rule is easy. You take the smallest number of sig figs in the calculation. Remember that back here? Smallest number of sig figs in the calculation. Oh, we got 1, so my answer is going to have 1 sig fig. Okay. The sig figs don't work that way in addition and subtraction. So if we go back here, let's see how much they don't do that. I don't know what jumped around on me so much. There we go. Where are we? Oh, let's take a look at this. How many sig figs in the number 9? 1. How many sig figs in the number 532.629? 6. How many sig figs in our answer? 3. Do those have any relation to each other in terms of 1, 6, and 3? Is there any way to figure that out using just those numbers? There really isn't. Okay, you cannot use the same rule. People just, you get one rule and you use it a lot. We use multiplication and division a lot more than addition and subtraction. So just keep the 2 rules straight in your head. Okay? All right. Another one, just going to prove how many sig figs do we have in 347.1? 4. Yes, 4 sig figs. 346.37, 4 sig figs. 5 sig figs, sorry, 5 sig figs. And our answer, if we believe what I've done here, has only 1 sig fig. So again, you can see that the sig figs in the question do not directly dictate the sig figs in the answer. What do you have to look at instead? Either look at the decimal places, where here we have 1 decimal place. Over here we have 2 decimal places. We do our calculation on our calculator and we get 0.73. So we need to round that to 1 decimal place, which means we get 0.7. The other way to look at it, my uncertain digit is in the tenths. So in my answer, I have uncertainty in the tenths. In my second number, the uncertainty is in the hundredths. So I also have uncertainty in my answer in the hundredths. How many uncertain digits am I allowed? Only 1. And so if both of those are uncertain, I have to get rid of that second one and just go to, sorry, that should be yellow, that one there, okay? And now we come to an example where decimal places are not so awesome, because how many decimal places are in the number 550 with no decimal? There aren't any, yes? 550 has 0 decimal places. But 550 also has 0 decimal places. This one has 2 sig figs, this one has 3 sig figs, and you will get a different answer depending on which of those you use in your calculation, which is why in this case, I would tend to go with the go to your first uncertain digit. 550, 2 sig figs, which means that our uncertain digit is that middle 5. Which means that that is in our tens position. So we will have an uncertain digit in the tens position in our answer. We also have uncertainty in the thousandth position in our second number. But that really doesn't matter, because if I'm already uncertain in my tens, what do I care what's going on in the thousandth position? Yes? So that's uncertain, that's uncertain, that's uncertain, that's uncertain. Which means that my final answer should go to my first uncertain digit, which is the tens, which means we need to look to the right of the 6. That's a 5, so we're going to round up and we get 570. How would you write that in scientific notation? Tell your partner. How would you write that in scientific notation? .7 or 70? 7, because there's only 2 sig figs. Times 10 to the 2. Excellent. 2 sig figs. And remember, don't chop the number off. Don't just cut it off when you hit your first uncertain digit. You cannot have a number that is 565 and round it to 57. That doesn't make any sense, does it? Hopefully it does not. Okay. I don't know that we need that example. We're going to skip that one and move to the last one because I like it. It really shows uncertainty really well. So here our uncertainty is in the thousands. And here the uncertainty is in the tenths. So we will have uncertainty in the thousands and in the tenths. So we did our subtraction. We started with 55,000 and we ended up with 54,923.8. But our first uncertain digit is in the thousands position. So we need to round to the thousands position. So we look to the right and that rounds us back up to 55,000, which is basically what we started with, even if we hadn't subtracted the 76.2. If you think about what 55,000 means, that would be plus or minus how much? 1,000. And that is way bigger than 76.2. So the 76.2 is meaningless in comparison with the uncertainty in the 55,000. If we're going to be out by 1,000, do I care if you've thrown in 75 or 76? No, I don't. Okay. All right. So I think we are good on that. I would like you guys to try these ones. Okay. So page 17. Woo, what am I doing? I would say the best thing to do as you go along is to practice underlining your uncertain digits. Add it up, underline in your answer, and round to the largest uncertain digit. Yeah. So I've put up there, do page 17. If you haven't already done page 21, if you did not do that over the weekend, you can do page 21. Maybe just do the odd numbers. And then page 22 is a mixture of multiplication, division, and addition. Oh. Yeah, if you're having any troubles with your calculator, let me know. I might be able to help you out. So I'm going to start you with get through all the stuff that we had for the lab, so you can take a look at it all. You may have some, you can always do it. But the other thing we did was we had post-lab discussions. Okay. And so those are the different groups that come out. Yeah. I have some quizzes to give back to you, I think, because I think I handed stuff back while you were. Yes, certainly. Well, I'm just going to hand back a few quizzes here, and then we'll have another mini lesson. Where did I put this block's quizzes? Block 7, that looks good. Okay, Carly, Molly. Oh, except for Molly, you're writing something. Bryden, Lance, Sasha, Sarah, Alex, Sarah, Alex, Sasha. Dayun is in the washroom. Yeah, you got full marks. Yeah, I think I wrote it on the other one. Yeah, Rex, Jilly, Julia, Hagen. Am I saying your name right? Okay, good. There we go. And Dayun. Yes. Your measuring quiz. I ought to do, yes. Now where is it? Because I marked it. I think you got perfect on it. But where did it go? It should have been with the rest of the quizzes. There it is. There you go. All right, we're gonna have another mini lesson. If you have not yet finished that stuff, don't worry about it. You can save that for homework for after the test. Tonight's homework is going to be to study for your test, okay? So don't worry if you didn't finish all of 17, 21, 22. Don't worry, you can go back to that after the test tomorrow. We're going to learn a little bit about multiplying and dividing in scientific notation. This will be a good review of the multiplication and division rule for sig figs, as well as a little review of scientific notation. So, one way of doing it is to use the EXPEE times 10 to the x button on your calculator. We will learn how to do that next day, so don't worry about that right now. Right now we're going to do it without that button, because sometimes you might, not have a calculator that has that lovely little button on it. Sometimes you might be borrowing a calculator and it's just one of those crummy little ones that you get from, elementary school or whatever, right? That just has times and divide by, okay? So what we're going to do is we are going to multiply the coefficients. We are going to add the exponents to get the power of 10. We are also going to, and it doesn't matter what order you do this in, you're going to put it in correct scientific notation and you are going to put it to the correct number of sig figs. Okay? So let's try this out. We have our coefficients, 3.42 and 4.67. And we're going to take those separately from the powers of 10 and just multiply them together. Okay, so we're taking our 3.42 and our 4.67, we multiply them together and we get 15.97. This is page 24. Now, if you have 10 to the 5 and you multiply it by 10 to the 9, what would you do with your exponents there? You would add them. So that's going to be equal to 10 to the 5 plus 9, which is 10 to the 14. So in other words, what we've done is we had a 5 up here, we had a 9 up here, we took 5 and 9 and we got 14. So our power of 10 is 10 to the 14. So now we have a power of 10 that has been multiplied out, and we have the coefficient, which has also been multiplied out. Now we need to do two things with this number. We need to round it to the correct number of sig figs, and we need to make sure if it is in scientific notation. If it's not in scientific notation, we need to change it to scientific notation. We're going to start, though, I think, even though I did it differently on here, we're going to start by finding to the correct sig figs. What did we just do with these numbers? Did we add and subtract, or did we multiply or divide? We multiplied. Therefore, we're going to use the multiplication rule. What is the multiplication rule? Multiplication rule, division rule, you're going to round to the least sig figs in the calculation. So we're going to look at our 3.42. How many sig figs in 3.42? 3. We're going to look at our 4.67. How many sig figs? 3. So I guess the least number of sig figs must be 3. Yes? Because, 3 is can't get, I don't know. I'm just going to stop that sentence because it didn't go anywhere. So in my answer, I want to have 3 sig figs. So we're going to have to take that 9 and look next door to see what to round it to. So that's going to be 15.9. We'll round to 16.0. Yes? So 15.9 rounded to 16.0. Now we have 3 sig figs. And it is still times 10 to the 14. So we check to see, now we have correct sig figs. Are we in scientific notation? And again, this is good review for your test. How do you know we are not in scientific notation? We have more than 1 digit in front of our decimal. So we need to then move our decimal 1 position over. So we end up with 1.60. We still need 3 sig figs, so we're going to keep that 0 on the end. This number got bigger or smaller? Smaller by 1 power of 10. Therefore, this has to get bigger by 1 power of 10. And so that will become times 10 to the 15. And that part right there, that going from 16 times 10 to the 14 into 1.60 times 10 to the 15, that is something that you could see on your test tomorrow. Yes, because that was part of our last unit. Not the multiplication, but just that last step of taking something that's not in scientific notation and turning it into scientific notation. Okay, we're going to do the next one, and you can just cross out the work that's here because apparently I had different numbers in mind, and it just didn't. Just cross it out. We're going to go from scratch here because the numbers don't match up. And I'm going to fix that in the future for next year. Okay, so we're going to take our coefficients, the 3.93 and the 4.67, and we're going to multiply them together. 3.93 times 4.67 equals 3.93 times 4.67 equals, and we get 18.3531. We have our powers of 10 here. We have 10 to the negative 2 times 10 to the negative 5. That's going to be 10 to the negative 2 plus negative 5, which is 10 to the negative 7. So now we're going to take these two parts and put them together. So we have 18.3531 times 10 to the negative 7. You could either change it to scientific notation right now, or you could check for sig figs. I'm going to check for sig figs. Why not? How many sig figs should we have in our answer? We should have 3 because we've got 3 sig figs here and 3 sig figs here. So we want to have 3 in our answer. So we're going to look to the right, and that's going to become 18.4. times 10 to the negative 7. We are not in scientific notation because just like last time, we've got 2 digits in front of our decimal. So we're going to move the decimal over 1 place. So we end up with 1.84 instead of 18.4. This got smaller by 1 power of 10, 10 to the 1, which means that our exponent must get bigger by 10 to the 1. What is bigger than negative 7? Negative 6. Make sure you don't go negative 8 because that would be smaller. It's those negative numbers, right? Okay. And that's basically it. Okay, so I think, yeah, no, that's it. So we'll leave it there for today. All right, and you guys can just study for your test. Alrighty?